Next, let's implement the method continue with. So what we'll do, we'll create a public Dome train task continue with method that accepts in an action. And this is the action that will execute once our current task has finished executing, or our custom task has finished executing, I should say. And inside of continue with, we're going to create our own Dome train task. And we'll go ahead and return that. But before we do, we're going to first see if it's already completed. And if it's not, then we're going to store the current state of this task so that we can use it later. Now, we're going to wrap this all in our lock. And again, this is an oversimplification of how .NET actually works. When we look under the hood, we won't see any actual lock statements. The .NET team puts in a lot of work to make sure that everything happens lock-free to avoid any performance hits the best they can. But here, we're not going to spend all that time implementing all of that, so we'll just keep using lock. But keep in mind, it's a little different under the hood. Okay, so the first thing we want to do is to see if this task has already completed. Because if it has, then we can just queue up on the thread pool. There we go. So we'll queue on the thread pool this action that we want to run. Now, we could just say action. We could just run it. And technically this is valid. But remember that with a task, we have to catch any exceptions that are thrown. And so what we actually want to do is create a try-catch block. There we go. And if the action completes successfully without itself throwing an exception, great. Then we'll say task.setResult to let the calling task know that it's been completed. And if there is an exception thrown, we want to catch that. And we want to say task.setException and pass in one that got thrown here. Set exception, there we go. Now, if the task hasn't already completed, well, then we essentially just want to save its state. But to do that, we first have to introduce a couple new fields. So let's scroll all the way back up to our previous fields. And what we want to do is we'll create private action. And this will allow us to save that action that the user is passing into our continue with method so that we can run it later once we're ready. And we also want to save something called the execution context. So let's call that context. Now, we haven't introduced execution context, and we'll dive a little bit deeper into it in the next section. But execution context is essentially all the information required for a logical thread. So the execution context is what stores all of the security information, all of the culture information that the current thread has access to. So as we can see here, the execution context is attached to this task, and it's loaded before this task executes so that the entire state is preserved as we switch between threads. Because remember, our code might have multiple threads running. Our code might be an API running in the cloud that has multiple users running on it. And we don't want to accidentally share information across threads, across users, unless it's on purpose. Execution context allows us to store all of that information here for us. So again, we'll dive deeper into this in our final section. But for now, you can think of execution context as all of the information about the current process, like security, identity, culture, language. And we're going to store that all here. So when that custom task runs, we've essentially stored its state. So what that means for continue with is in this else block, if our task hasn't already completed yet, well, we can't run the action because this is called continue with. So we need to first complete the current task, then we can run that next action. So what we'll do is we will store the user's action here under our field underscore action, and we'll grab the current execution context, and we'll capture that execution context here so we can store all the information about this thread. Now, before we can run this new continue with method, we first need to update setResult and setException, because if we look at the code here, running continue with before the current task has completed. So if the task is not completed, we just store that action and the execution context for later. But down here in setResult, we don't ever check to see if there is a continuation. So the first thing I want to do is actually combine these two methods. They're kind of similar. So let's create a private method called, we'll call it complete task, where we'll pass in an exception. And here, let's copy paste some of this code. And we'll point setResult to complete task null, because there is no exception when we call setResult. And setException, we'll call complete task, and we'll pass in this exception here. Okay, great. So now we know that when we complete the task, again, if that task is already completed, we're going to throw an error. Tasks can't be completed twice, so something's obviously broken. We want to ensure we set completed to true. Beautiful. And now we can check our new field. And if that action's not null, well, first, let's check to see that execution context. Because if that execution context is null, then we can just run that action. We can just say action.invoke. If the execution context is not null, then we need to tell .NET to not only run this continuation, but to run it on the specified execution context. And the way we do that is we can call execution context.run. And the first thing we do is we pass in the execution context. And the second thing we pass in is the callback. But let's jump to the third parameter, state, because this state is going to be our action. And this makes the second parameter a little bit easier to understand, because the way it works is that action here, this state, gets passed into this variable. So for this context callback, we say state goes to, and then we know that we're passing in an action here. So we can say action state and cast that so that we can just go ahead and invoke it. And now our code's running on the execution context that is required. And let's go ahead and fix this nullability warning. There we go. So again, when we complete a task, whether that's by calling setResult or setException, we'll enter in our lock, which again, remember, .NET doesn't actually use locking under the hood. They have their own intricate way of ensuring that there are no locks, but we're cheating a little bit. And to see if that task is already completed, because it can't be. So if it is, something's gone wrong under the hood. We'll set completed to true. We'll set the exception if there is one. We'll look to see if the user has already called continue with, and if there's an action pending. So if there is not, we'll just finish this method. But if there is, we'll go ahead and run it, ensuring that it runs on the proper execution context. Now let's jump back to our console application and see how this code all works together. Okay. Now, the first thing I noticed is I got a recommendation here that says to use environment.currentManageThreadID. So let's switch these over. And now what we're going to do is we're going to add a continuation onto our DomeTrainTask.run. So let's come here and say continue with, and let's just pass in another console.writeLine where we'll grab the current thread ID. Now, let's go ahead and change these a little bit just to make sure we don't get confused. Let's see. So instead of saying current thread ID, let's say starting thread ID. And then we'll say this is the first DOM train task ID. And then this is the second DOM train task ID. There we go. And the console read line will ensure that the application doesn't finish before I tell it to, which means both these tasks should finish running, and we should see 3 console write lines. Let's go ahead and run this code and see how it looks. Okay, look at that. In our console, we see that the starting thread ID is 1, and that the first DOM train task ID was 4. And then since we called continue with, the second DOM train task ID was also 4 because it resumed on that same captured context. Now, for example, if I had changed this to say, instead of continue with, if we had done another DOM train task.run instead, let's see what the results would be here. So if we run it again, of course, we're going to get a different background thread ID each time for our first DOM train task, because we're just going to the thread pool and grabbing whichever one's available. So if thread 4 is available last time, this time was thread 5. And then the second time we go again to just grab whatever thread is available. So we got 2 different background threads. But with continue with, if we control Z some of this code and we run this code again, continue with will always ensure that we continue onto that previously captured execution context. In this case, showing us here that we have the same thread ID. Now, something we could do here is we could write this code a little differently to really highlight what's going on, because DOM train task.run returns a task. So this is our DOM train task. There we go. And what we can do is say task.continue with, meaning we don't have to necessarily chain continue with on to the existing method call. We can actually create a variable, then call continue with. And let's put these in curly braces too, to really show that this continue with is continuing from DOM train task.run, which we know is going to run on a background thread, which is why we expect the second DOM train task ID to be the same background thread once it's printed to the console. Now, something crazy I'm going to do here is inside of continue with, I'm going to say DOM train task.run again. And we're going to say here, third DOM train task ID. Now, the way we've written this code, it's a little out of order, but if we think about what's going to happen is thread 1, the main thread, is going to first execute console.writeLine, where it's going to print that our starting thread ID is 1. Then thread 1 news up this DOM train task that we named task. So thread 1 is going to kick off DOM train task.run, which we know because we wrote the code that it essentially defers to a background thread. We're going to queue this work to happen on a thread from the thread pool. So what that means is this is going to continue on in the background, and we're going to return almost immediately as far as thread 1's concerned. So thread 1 writes that our starting thread ID is 1. Then it's going to queue up DOM train task.run onto a background thread. And then it's going to, thread 1 is going to jump straight to this line where it's going to say continue with, which we again know just queues up that action, right? So it's going to enter in our continue with method, where we're going to see if the thread's completed, which it's not yet. And so we're going to capture that action. We're going to capture the